Okay, this lesson will cover the concept of percent concentration within pharmacy calculations. And there's really three types of percent concentration that we talk about. Percent weight and volume, and percent weight and weight. And here's their respective abbreviations. So for example, if a concentration is indicated to be a weight to volume concentration, what that really means is we're talking about, there's going to be a little arrow here, is that means weight to volume in terms of a percent concentration, that will always be grams per 100 milliliters. Remember that when you hear percent, you should always think per 100. So for example, if it is a 3% weight to volume concentration, another way to express that would be 3 grams for every 100 milliliters. Okay? And up here in our notes it says weight to volume, so it expresses the number of grams of constituent in 100 milliliters of solution or liquid preparation, and is used regardless of whether water or another liquid is the solvent or vehicle. Okay, so again, 3%, for example, would be 3 grams for every 100 milliliters. That's how you would translate that. Okay, so what about volume over volume concentration? Okay, so that would be, so let's say that basically means the number of milliliters of constituent per 100 milliliters of the total solution. Okay, so an example might be, okay, let's say you have a solution that has an 8% concentration of the constituent. So that means 8% would translate into, that's a percentage sign there, 8% would translate into 8 milliliters of the constituent per 100 milliliters of the total solution. Okay, and then finally, weight to weight. So that basically means number of grams per 100 grams of the total product. Okay, so an example might be, well, perhaps a ointment has a concentration of 2.5% of the active ingredient. So that would translate into 2.5 grams per 100 grams of the total product. So these are three examples of the three ways of how to express percent concentration within pharmacy calculations. It will be useful for you to have this handout printed out. And then we have some examples to look at to help you better understand how this works. Okay, here's an example problem for us to take a look at to help us better understand percent concentration. Here it says a 30-gram tube of ointment contains 0.5 grams of hydrocortisone. What is the percent strength of the hydrocortisone? We'll round our answer to the nearest tenth. Notice here, first thing is percent strength, percent concentration. Those terms are generally used interchangeably. So it's really asking, what's the percent strength? Now, for this problem, it doesn't explicitly state which type of concentration it is. So remember, we have three choices. So, it could be weight to volume. Let's write our choices here. It could be volume to volume, or it could be a weight to weight concentration. But eventually you should be able to get to the point where you read a problem like this and it becomes pretty intuitive which of these concentrations it is. So notice it mentions a 30-gram tube. The quantity in the tube is described as, well, being 30 grams, so that's a weight. Here it says, but then the constituent or the active ingredient is 0.5 grams of hydrocortisone. Also, it's quantified as a weight in grams. So this is a weight, this is a weight. So it becomes obvious it's going to be a weight over weight, weight to weight concentration. Okay, so we got 0. So conceptually, what we need to do is think of, well, it's 0.5 grams within the 30-gram tube of the product of the ointment. Now, for the concentration, though, to figure out, what's the percent concentration, because percent is per 100, in this case, per 100 grams. So we just need to find out, well, we know there's 0.5 grams in a 30-gram tube. Well, how many grams would be in a total quantity of 100 grams of the product. So we can set up a simple proportion like this. We're going to solve for x, and we end up with, we'll round it to the tenths place as the instructions indicate. You should end up with a 1.7. So that's 1.7 grams per 100 grams. And because that's per 100 grams, this is the percentage. We can put a percent symbol there because this is per 100. Okay, so that's how we converted. We took the information here, 0.5 grams per 30 grams. We converted that to a percentage. So that is our percent strength of the hydrocortisone in the ointment. Now, here's another note. This is the concept right here. Now, there is maybe a quicker way. You don't always have to write out the proportion here. Once you have the correct units, grams per grams here, if it was, let's say that it told us how many milligrams of hydrocortisone was in the ointment, well, then you'd want to convert those milligrams to grams, because when we're calculating percent strength, weight to weight, it needs to be grams per grams. But once you have it grams per grams, you have a fraction here, 0.5 over 30. Well, then you can just follow an algorithm to convert a fraction to a percentage. And of course, that algorithm is the numerator divided by the denominator times 100. And if you do that, you're going to end up with, rounded to the tenths place, you'll get 1.7. Okay, and of course, this is our algorithm to convert it to a percentage. That's a percentage. Okay, so either way you get to the answer, this is the concept. This might be a faster way to actually get the answer on a test or a quiz. Okay, here's example number 2. And it says a solution contains 3 grams of sodium chloride in a volume of 80 milliliters. What is the percent concentration of sodium chloride within the solution? We can assume that's what it's talking about. And it says round our answer to the nearest tenth here. Okay, so again, we're always choosing between 3 types of concentrations. Weight to volume, volume to volume, and weight to weight. Well, let's see. A solution contains 3 grams of sodium chloride. So this is the, you can call this the constituent or the active ingredient. So this is described as a weight. That's grams. I'll put W for weight here. Over here, 80 milliliters, that's obviously a volume. So it becomes obvious this is going to be a weight to volume concentration. Okay? So again, it's a weight to volume concentration. So what is the percent concentration of the sodium chloride in this solution? So we got 3 grams over 80 milliliters. But of course, percent concentration, we're talking about per 100. And we know that if it's going to be a weight to volume concentration, it needs to be grams per 100 milliliters. So per 100 milliliters. So again, we can set up our proportion. This is the concept. Put an x here, solve for x. And of course, you do your simple algebra. You probably end up doing 3 times 100 divided by 80. Round it to the tenths place. You should get x equals you get 3.75, but of course that rounds to 3.8. And this is per 100, so then we know we can put a percent symbol here because that's a weight to volume concentration. That's talking about per 100 milliliters, so that's why we can put the percent symbol here, 3.8%. And of course, as mentioned in the previous example, once you get this fraction here, 3 grams over 80 milliliters, and the units are appropriate for percentage concentration, weight to volume, grams over milliliters. Once it's grams over milliliters, you got your fraction. You can just use numerator divided by denominator times 100. That'll also quickly get you to the percentage. Again, this is the concept though. Here you're told it's 3 grams per 80 milliliters. Well, we need to know how many grams per 100 milliliters because that is what percentage is, percent concentration in this case. Okay, example number 3 says a dermatological lotion contains 1.25 milliliters of liquefied phenol and 500 milliliters. Calculate the percent strength of liquefied phenol in the lotion. Okay, well, of course, we have 3 choices here. We could decide if this is a weight to volume concentration, volume to volume, or weight to weight. Well, if you look at the problem here, it says the lotion contains 1.25 milliliters. That of the liquefied phenol, that is the constituent. This is described as, milliliters. Of course, that is a volume. Okay, then over here at the 500 milliliters, that's the total volume of the solution. That is also described as a volume, milliliters. So obviously it's going to be a volume to volume concentration. All right, well, and volume to volume concentration, so that means it's got to be a certain number of milliliters per 100 milliliters. We'll set it like this time. But in the problem it says we have 1.25 milliliters per 500 milliliters. Okay, but again, to get to express this as a percentage, we need it to be, instead of per 500 milliliters, it needs to be per 100 milliliters. Well, we do some simple algebra. We solve for the x, and so x is going to equal 0.25 milliliters. Now, this is 0.25 milliliters per 100 milliliters. So this is why, because it's per 100 milliliters, it is 0.25%. We can write it like this. That's why I can put the percent symbol there. Okay. And as mentioned before, this is already the appropriate units for a volume to volume concentration, milliliters over milliliters. Once it's like this, you're basically, to get to your answer, you're just converting this fraction to percent. Numerator divided by denominator times 100. But again, this is the concept right here. Okay, here's example number 4. It says a formula for an antifungal shampoo contains 2% weight to volume ketoconazole, and how many grams of ketoconazole would be needed to prepare 240 milliliters of the shampoo? Here it does explicitly state that it is a weight to volume concentration. But if it didn't tell us that explicitly, here we see it's how many grams, so that's a weight, of the ketoconazole would be needed to prepare 240 milliliters, which would be a volume. So we could quickly see this is definitely a weight to volume concentration, which is consistent with what they tell us right here. Okay, so they're asking, let's see, formula. They tell us the percent strength right off the bat here, but then it says, well, what if you need to make 250 milliliters of the product here? How many grams the constituent will be needed? So 2%, we could rewrite that as 2 grams for every 100 milliliters. And they tell us the total product is 240 milliliters. Of course, the total product would be in the denominator. What also helps you see that is that, of course, we want our units to line up here also. But the main thing is that to prepare 240 milliliters, you would put that in the denominator, and the amount of the constituent would be in the numerator. I'll put x here. So x is going to equal, so we'll solve for x. Do our simple algebra here. End up doing 2 times 240 divided by 100. And for this one, we would end up, let's see, punch that into our calculator, and around to the 10th place in this case, you should get x equals 4.8. And that, of course, the units of the x is grams. Now, here we're just calculating that we are told the percent strength, and we rewrote that as 2 grams per 100 milliliters. Now, unlike the other examples, we had to find the percent strength. So here we're just using the percent strength to find out, well, how many grams of the constituent will be needed to make 240 milliliters of the product. So again, we're not going to put a percent symbol here because this is this is per 240 milliliters that we're finding. We were already told the percent strength, which is 2%. All right, so 4.8 grams out of 240 milliliters, that would reduced to 2% strength. Okay, but here's our answer: 4.8 grams. Asks how many grams. So 4.8 grams of the ketoconazole in 240 milliliters would give us a 2% strength. Okay, here's example number 5, and this somewhat introduces a new concept. Express the ratio 1 to 3,000 as a percent strength. Another way to express concentration is to simply express concentration as a ratio, in this case 1 to 3,000. So for example, if we were told that this is a weight to volume concentration, and our answer will not change regardless of what type of concentration it is, but this was a weight to volume concentration. What this really would mean would be 1 gram for every 3,000 milliliters. Okay, because weight to volume concentrations are always, we always need to, if they're not already in this form, we need to get them to the point where they are grams per milliliters. Now, of course, this is not a percent concentration yet because it's not per 100 milliliters. So to get to a percent concentration, we need to rewrite this ratio so that it's per 100 milliliters. I'll put an X here. So we will, of course, we do our algebra. 1 times 100 divided by 3,000. We should get 0.0, it says round to the thousandths place, 0.033, okay? And this is going to be grams per 100 milliliters. But because this is per 100 milliliters, this is what the percentage is. We'll put a percent symbol there. Okay. So very simple. 1 to 3,000, and to quickly get to the answer, you're basically taking numerator divided by denominator, multiplying times the 100. That's how we got 0.033. Because now, since this is the number of grams per 100 milliliters, this is the percent strength. That's why we can put the percent symbol there. Okay, here's example number 6. Here it says express 0.04% as a ratio strength. Well, ratio strength, when you hear ratio strength, that basically means that it's telling us we need to put this in the form of 1 over a numerator. Okay, so right now we know that, let's say this could be a weight to volume concentration or a weight to weight concentration. Doesn't particularly matter, but we'll just say it's weight to volume. Okay, so that would mean that this is 0.04 grams per 100 milliliters. Okay. If it was a volume to volume concentration, it'd be 0.04 milliliters per 100 milliliters. But we'll just run with this example, weight to volume. So to get it to a ratio strength, we need to put 1 in the numerator and determine what the denominator would be. So we'll put X where the denominator is going to be. Okay, so we'll do our simple algebra here. 100 times 1 divided by 0.04. We should end up with X equals 2,500. Okay, so that basically means our ratio is going to be 1 to 2,500. So if this is a weight to volume concentration, it would mean it would be 1 gram for every 2,500 milliliters. Okay, but again, so in this case, the ratio strength is 1 to 2,500.